Good morning. My name is Matthew Kerner. Thank you so much for joining us this first session of the morning to talk about blockchain on Azure. It's delightful to speak with you. We're going to cover three things today. First, we'll talk about what blockchain is. Then we'll talk about what we have been building to make it easier for you to develop with blockchain on Azure. And then finally, we'll talk about what a variety of customers of ours are doing, including having a customer join us on stage. So, the tricky thing about talking about blockchain is that there's a wide range of depth of knowledge in any audience that I speak with. Some people are blockchain-erati and they've been in it for years, and others are brand new and know that it's something that has a lot of hype. So I will do my best to make this talk relevant to everybody. But if you are deep in blockchain, please bear with me for the next maybe 5 minutes as I repeat some things that you probably already have heard. Blockchain is a technology that enables you to share business processes and data across a large number of counterparties who don't trust each other. That's what it does for you. And it consists of an abstraction, which is a ledger. And if you've ever read an illustrated book from the time of Charles Dickens, you might have seen a picture of a clerk with a quill scribbling in a big leather-bound book with a green visor and some armbands by candlelight. And that clerk was probably writing in a ledger. A ledger is an accounting book, and there are lines, and you record debits and credits. And the intent with a ledger is that you only ever add new entries. You never scratch out or modify an existing entry. That way, somebody can go back and check your work and make sure that you weren't cheating. Every mistake is dealt with a compensating transaction. And that's exactly what the ledger is that runs in the world of blockchain. But the ledger in blockchain is a little bit different because it's a ledger. It's not just one ledger. It's a ledger that has many, many copies, one copy for each member of the network. And it could be on a public network. It could be every node that's part of the public network. In an enterprise consortium context, it might be a node or a set of nodes for every single organization that's in the enterprise consortium. And there are a set of cryptographic schemes and distributed systems protocols that enable communication among these independent ledgers and ensure that they all stay in sync and that the updates that they make are all consistent across them and that the data that's put into those ledgers remains immutable and that all of the changes that are pushed to the ledger are trustworthy in the sense that they come from an authorized party who's authenticated in some way. And so that is the basics of what blockchain is about. And blockchain is really based essentially on cryptography, and there are a set of concepts. I'm not going to go deeply into these today. If you are curious, you should check out Mark Russinovich's talk, which is this afternoon at 2:45, Ballroom 6E. It's BRK 2507. Mark is the CTO of Azure, and he's going to spend an hour talking about these concepts deeply. So if you're curious about the nuts and bolts of how blockchain works, that's the talk to go to. I will talk about smart contracts because I think that's important for the discussion that follows. Smart contracts deal with this problem, which is that most business processes, real business processes, are not just a single-step process. If you consider a supply chain, there's an order that's placed. Perhaps there's a bill of lading. Perhaps there's an invoice. Perhaps there's a payment. There are a variety of different instruments that flow back and forth between counterparties. And for that business process to complete successfully, you need a trustworthy execution of that process across all of these different steps. And blockchain needs to be able to support that, and smart contracts are the mechanism that enable you to support that because you have to know what's going to happen in the future. And the way that that's handled is that in blockchain we can put code on chain, not just data. It's not just a ledger where you're recording the transactions, but you can actually put business rules on the blockchain. And those business rules are immutable, just like the data on the blockchain is immutable. And those business rules are shared. So all of the counterparties can inspect those business rules in advance, decide that they like what they're going to get, and then they can count on getting what they saw at the beginning because it's immutable and it won't change on them. Let me give you a very simple example. I have a colleague, his name is JT. He just bought his first house. So in honor of his house purchase, we're going to go through an escrow example, and my colleague Alice is going to be the seller, and JT has some cash, and I am going to be an escrow agent who may or may not be trustworthy. And I'm in the transaction because JT and Alice don't entirely trust each other, right? So JT is going to transfer his cash to me. I've now got his cash, and I will decide whether to pay the cash to Alice if the house is delivered or give it back to JT. But I could do a third thing, actually, and I'm not sure how frequently this actually happens, but let's just say that I skip town with the money. Well, now JT and Alice are not particularly happy, and the only thing that prevents me from doing that is that I might get arrested, and there might be a charge of theft. I don't know it's probably a felony. So if that's not something that bothers me, and it happens to bother me, but if it didn't, I could go run away. Sort of the interesting thing that smart contracts let us do is it doesn't replace my job as an escrow agent, but we can augment me as an escrow agent with some code that's going to put some guardrails around what I can do. So now JT doesn't give the cash to me. JT gives the cash to the smart contract. And the smart contract is an agent that can hold an asset, and it can decide what to do with that asset. And I'm now casting the deciding vote. If I decide that JT is the one who ought to get the money back, I can sign a message along with him, and then the money will go back to him. And if I decide that Alice should get the money, Alice and I can each sign a message, and it'll go to her. I can't pay the money to myself, so that money is not coming to me. Now, I could still be unpleasant and skip town. And if I did, even though the money's not coming to me, I'm less happy. But also, JT and Alice are still unhappy because now there is no way for them to get that asset out of the smart contract. Again, these transactions are reversible, they're immutable, you're stuck. That money is now locked up in the smart contract forever. So, whoops, let's fix it. It's PowerPoint, I can. So I'm going to add a new clause, which is that if JT and Alice decide together that I'm not a suitable escrow agent for whatever reason, they can designate a new one, and then that new one can cast the deciding vote. And this, I think, is a pretty good solution to this problem. Beware smart contracts, because in the real world, you can't just go and modify them by adding the new clause. If you want to build systems that have mutable smart contracts, you can. It's pretty complicated. You basically have to model code as data and have a smart contract that can call different addresses depending on how it's configured. And then you've got to secure that thing so it doesn't become a point of failure or attack. So there's this kind of complicated set of things you need to do to use this in the real world. But this is the basic concept of what smart contracts can do. And if you back up from all of this and you look at the combination of blockchain distributed ledgers that run in this decentralized way across multiple counterparties plus smart contracts, you end up with a kind of an interesting value proposition. Because today, many of these business processes involve a tremendous amount of manual reconciliation, wet signatures, faxes, phone calls. All of that friction can be eliminated when a process can be digitized, or at least can be reduced. And that digitized process can run on blockchain rails, even across many different counterparties, even if they don't trust each other. And in contrast to a centralized system, a variety of risks are eliminated. Nobody notices if a blockchain node is compromised. If the network is large enough, nobody notices. It doesn't matter. It doesn't affect the functionality of the network. The only thing that people notice is if the keys are compromised. So if you have good key management, you can run a very secure system, even across many less than fully trusted parties. There's also a variety of other risks with centralized systems that you can eliminate. You no longer have a centralized point of authority who can decide to charge you high rents or start to deny you service or change the game on you or gain some competitive insider advantage in the market that by virtue of their position as the central intermediary. So that risk is eliminated. And if you have a centralized system, of course, it becomes a big point of attack for any kind of adversary that might be out there, and they can really concentrate on subtle bugs or 0 days or what have you. So a variety of risks can be eliminated. And the last thing is this ability to connect all these different counterparties means that you can start to perhaps collaborate in new ways in your market. Maybe you have a legacy architecture for your market where the business processes are complicated, and you can now create direct connections with a variety of counterparties that you couldn't reach before. So you can really reimagine the way that business works, and in the same way that you might digitally transform a business inside of that organization using standard cloud technology, you can now look at transforming multiple organizations' business processes this way, outside the four walls of one organization. That's a really interesting thing that blockchain really lets you do in a unique way. So that brings us to the end of what is blockchain. And again, Mark Russinovic's talk this afternoon is the place to go if your appetite is now whetted and you want to learn more. I would like to now talk about what we're building that we think you could use to make blockchain applications more easily. What we hear when we talk with customers, developers who are building blockchain, is they would really like to focus on the business logic that they'd like to put on the blockchain. But they end up spending their time on a variety of other things. Boy, I'm doing all of this undifferentiated heavy lifting to set up infrastructure and keep it running. That isn't unique to blockchain, and it doesn't leverage my skill set. boy, it's really expensive to build an end-to-end application on top of blockchain, and it takes many months, and my organization doesn't have the budget or the time to wait for me to get to a proof of concept in that way. Or, boy, at the end of this, I ended up with this monolithic application that was brittle, and when somebody asked me to make a change to it, it was a disaster because I had to do the whole thing over. These are things that we hear routinely from developers who are working to build blockchain. So we're trying to do a few things to make that easier. The first of those is making it really easy for you to get your blockchain network on Azure without worrying too much about the infrastructure. Second thing is we've built a variety of integration points with Azure services, so you have the full end-to-end stack that you will need in order to build a production application. And you can then customize it and go from there. And then the third thing that we've done is we've built some UI to make it easy to leverage all these things. So let me sort of take you through this. I'll cover the surface area, and then I'll demonstrate it for you. The first thing is the ledgers. You can go to the Azure Marketplace and find 40 different blockchain solutions available for deployment. You do not need to set up your VM. You don't need to download bits. You don't need to configure them. All of that is taken care of for you. And you can deploy single node if you want to do dev test, or multi-node in your own subscription if you want to try out what a consortium might look like. Or you can even deploy multi-member, where individual organizations with separate subscriptions and separate administrative control each deploy their own footprint of nodes and then join those together with a VPN network. And then they have this private consortium network that's not under centralized control that can communicate with each other. And so all of this is intended to help you set up the plumbing with minimal friction and effort. The thing is, when developers have set up the plumbing, one of the things we've heard when we've called customers who were using this is, you made it so easy for me to stand up the plumbing that the barrier to entry was gone. And then as soon as I did that, I hit the next wall, which was I didn't know what to do with it. And so I gave up. I looked around. Nobody really had a good answer. It seemed like it was going to be months of work, or I'd pay hundreds of thousands of dollars to somebody with specialized skills to do the next thing, and I'm done. So I'm just going to delete that thing because it's spinning meters and burning money. So what we've done is we've sort of filled in the blank space, the white space between the ledger down at the bottom, which is the plumbing, the multi-party data layer, and all the apps and devices and services that you might use at the top that already exist in your business. And that's this thing that we call Azure Blockchain Workbench. And so it lets you run workflows on blockchain across multiple different counterparties with a single view of data. It takes care of your identity for you because it uses Azure Active Directory. So your users no longer have to manage wallets, which is a tremendous headache. You can just log in with single sign-on with your corporate credentials. And your keys are managed for you in Key Vault. And signing is already taken care of, so you don't have to worry about that. The architecture here is ledger neutral. Today, what is available for you to try works with Ethereum, but we have a private version that works with Hyperledger that we'll be releasing, and we're working on Corda now. So you'll be able to use multiple different ledgers with the same architecture and the same API surface area. And there's an API, which is a REST API. There's also a messaging scheme. So you can connect this up to your existing applications using all of the existing skills and tools that you already use. You don't have to do anything special for blockchain there. And when you create these workflows or these applications that run on top of Workbench, we automatically create for you a basic UI experience. So you don't have to write a line of UI code, and you can go through the whole multi-party workflow, you and your other counterparties, and try it and make sure that it works. So we make it easy for you to rapidly iterate on that. And you might not go to production with that UI that we give you. You could build your own, but at least it gets you started quickly. And then there's an administrative experience, so you can add these new workflows and you can configure which users can participate. And then all of the data is put into a traditional Azure SQL database. So if you want to do reporting or pull it into other applications or access it in other ways, you can do that. You don't have to speak to the blockchain-specific APIs if you don't want to. So that is the surface area of Workbench. The thing is, let me sort of take you through this because there's a bunch of stuff. You've got your data sources and your users and your devices on the one end that are providing a set of inputs. Those inputs go to this set of resources that are in a resource group. AAD and AKV are used for identity and key management. You've got app insights to understand what's gone wrong, if something's gone wrong, and then you're isolated in your own virtual network. And the first thing that receives those messages is an API endpoint that then delivers those in the right format to a service bus instance. Service bus can then send those things to 3 different places. The first is we have this microservice that's responsible for receiving requests, laying out transactions in the format expected by the ledger, using the right hashing function to summarize that data, and then signing it with the right signing algorithm, using the keys that are in Key Vault for the user who's authenticated when they called the API or delivered the message to service bus. And then that's delivered to the ledger by that service. The second thing is we've got a facility for storing data off-chain. So if you want to have documents that are part of a solution, and you, let's say, hash those documents, and you put the hash on-chain, we provide you an easy way to put those documents into Azure Storage. And then we have a database, and that database reflects the state shown on the ledger, and we keep it up to date. We have a watcher that looks for transactions on the ledger and then updates the database. And then that database can feed a variety of different scenarios, whether you want to use logic apps to do integration or Power BI for reporting, or you'd like to just feed this to other applications. And we can also publish these things to Event Grid so you can pick them up in a messaging-based scheme. Then you can connect up whatever services you like. And sometimes those services actually want to initiate transactions. So you can actually use the service bus instance to push messages that will drive activity, as well as the REST API. And so you can use Azure Functions to generate these messages. They can consume a variety of different data sources. And so the intent is that you can have a workflow modeled in Workbench that drives a bunch of external activity. And you can have existing systems of record, whether it's your ERP or CRM system, that drive a bunch of actions involving the blockchain in the other direction. So you can go both ways. And the intent is this should just fit right into your existing IT footprint. It should not be that blockchain is some island off on the side that nobody can talk to, that it really can talk to your systems of record and enable you to interact across counterparties. And then there's the UI, which I will show you in a moment, which puts kind of a skin on top of this and lets you experience those workflows. In order to show this workflow, I want to talk about a customer, Nestle, who is building on Workbench today. And they have these famous and delicious Baci Perugina chocolates, which they're working on the supply chain for with Workbench. But I'm going to talk about it in the context of ice cream, because I think ice cream is interesting because it can melt. And you can imagine a factory produces some ice cream. They stick the ice cream on a truck, and the truck drives off, and the carrier is driving along, and the driver wants to save on fuel, so he shuts off the freezer, and the ice cream all melts. And an hour and a half before he gets to the store, he turns the freezer back on, and the ice cream all freezes. And then he gets to the store, nobody's the wiser until customers start to get sick, and then the store is a crisis, and the ice cream brand is a crisis, and nobody realizes that it's the driver. Now you might say, wait a minute, this is a solved problem. Let's stick IoT devices in there and detect when the temperature drops below or above a certain threshold. That's great, but you still have the problem that that IoT data is going into some central system. And the manufacturer and the retailer and the shipper might not agree about what actually happened, or they might dispute it. You might get into an argument. Yes, I know the ice cream melted, but I don't really trust that data. How do I know that your IoT sensor was really there? How do I know that you didn't tamper with that data after it arrived at the back end? There are a variety of reasons why that situation might not, or that solution might not be enough, especially in a complex multi-party supply chain. So the beauty of blockchain is every single counterparty has their own infrastructure deployed. Their data is synchronized. Every single update has been signed, so you know where it came from. And there's no dispute about what the data says. Now, we can talk about who should be liable for it or how we want to deal with the problem, but there's no argument about what happened, where it happened, in whose responsibility the ice cream was when it happened. And so that's what I want to show you. And what we do with these sorts of business processes is we have to reduce them to something that can be implemented. And we create a state machine. The state machine models the business process. One of the developers on the team, Ramya, built some really nice diagrams for the samples that are available on GitHub. And this is one of them. We call it telemetry compliance, but here we're using it as refrigerated transportation. And there are a variety of states and transitions. There are a set of roles that have permission to trigger those transitions and data that can accompany those roles. And then this is what we model. And there are failure states and success states. And this is what ends up going into Workbench. So let me show you Workbench now, and we can just go through it. And pardon me while I switch over to my mouse so I can give you a demo of it. All right, so here's the Azure dashboard. I'm going to go ahead and click Create a Resource. And go into Blockchain. And why don't we just see all of them? So, you have 40 of these things in a variety of categories. Tools, single and multi-node ledgers. Here's Azure Blockchain Workbench. We've tried to make it easy for you to find it. So I'll go ahead and click Create. And you can see you get a variety of Azure resources. We believe that many blockchain applications that get built are going to look different from each other. And so we don't think you should end up with one monolithic thing, which is your blockchain application. We think it's better if you end up with a variety of Azure resources that are wired up and talk to each other in a pattern that we would recommend. And then you can go from there, and you can change all of these things as you see fit. And if you decide to scale this thing up to production, these services will scale with you because there are hundreds of thousands of customers using these services in Azure today for production workloads in the enterprise. And so you can just continue to do that. And so I'll go ahead and click Create. And I'm not going to go through this whole creation. I have one already. But you can see this is sort of the standard experience of deploying these things. And you'll put in a variety of configuration settings, and then you'll be off to the races. And so this will deploy. Now let me jump over to Workbench itself. So the first thing you'll notice is that I've got a set of applications. And by the way, what you didn't see was it just logged me in with Azure Active Directory. And when I show this to customers, sort of in a one-on-one setting, after I explain that, they're like, OK, we're sold. We want to use this. And I'm like, well, I haven't shown it to you yet. And they're like, you just solved my identity problem. It's a disaster with blockchain. That's all that I really wanted. Everything else I can figure out. So the fact that identity just works with single sign-on is huge. So I'm Matt Kerr at ntdev.microsoft.com. Here I am. I'm logged in as Matt Kerr at Microsoft.com. So I can create a new application. And in order to do that, I need to add 2 files. Let me show you what that looks like. The first is a JSON file. That is the configuration. This contains the set of states that are in that diagram. And actually, before I go there, let me go to the samples. So this is available for all of you. And if I go in and I choose smart contracts, I've got a variety of them. I'll just go into this digital locker. That's the one I happen to pull. You can see that we've provided some explanation of what the sample business processes that we've modeled. Who are the roles? What are the states? What's the workflow detail? Why does it work the way it works? And then what are the files? These are those files. The first is a JSON file that describes those states and those roles, who's allowed to make the transitions, what fields exist. And so it's very straightforward. I'll just scroll down. You'll see there's nothing very fancy here. Here are the states. Here are the fields. Reject application. Here are the transitions. Great. Then we have Solidity. Solidity is the language that Ethereum uses to implement smart contracts. And up at the top, I've got this Workbench base, which is the base class, and then you create classes of that type down below. And so that's sort of boilerplate. And then here we are. Here's our digital locker contract. And it's got some fields, and then it's got a constructor, and then it's got these functions that are that contain the business logic that needs to be enforced upon the state transitions. And so every single state transition in that state diagram comes along with a smart contract function. And so you write these. There's no getting out of this. This is the yeoman's work that you do when you build a blockchain application. Sorry, we can't solve this one for you. So you go ahead and you write these. And if you want to know more about the configuration and the smart contracts, check out the documentation on docs.com, docs.azure.com. It's all there. And there are a variety of samples in GitHub that are kind of that are fully featured. So let me go ahead and go back to Workbench. And I'll just add an app so you can see what that looks like. So first I need my JSON. Oops. First I need my JSON. And it's not really demonstrated here because this one's well formed, but there's a checker that runs. So if you've got something that we can detect that's wrong with that, we'll tell you. And that simplifies things tremendously. And then I'll go ahead and I'll find the smart contract file. Great. Then I hit deploy. And then I've got digital locker. Then the next thing I need to do, and I'm not going to use that one. I'm going to use this refrigerated transportation. Let me go into that. There are a set of members who have roles. And this is just Azure Active Directory, so I could add someone. Let's see. Michael Glaros is my colleague sitting in the back. Hey, Michael. You're going to be an initiating counterparty. OK, great. So Michael's added. So that's how role-based access control works. And by the way, the enforcement of those roles is performed on the blockchain. So you could have multiple different counterparties, each running their own instances of the ledger. And then you've got Workbench over here running on top for one user. And even if they go in and try to directly call the smart contracts on the blockchain, if they don't have the key that corresponds to that role, they're not going to be able to drive the transitions that that role can drive. So here I have refrigerated transportation. Let me go ahead and just show you a transaction here. This is one that previously ran. You can see the transaction as a set of details, the fields that were set, and then there's a history of actions that were taken on it, and for each one I can see the detail on what occurred. So I've got the time and the block and who I transferred this contract to. And so now let me create a new one and show you how it works. So I'm going to go ahead and I'm going to use this device. This is my IoT device right here that's traveling along with the ice cream. And then I've got a gateway here that is set up to be able to report telemetry through IoT Hub in Azure. And then I'm going to say I'm the one who's the owner of this process. I've got some food inspector who's participating. And this shipment needs to be within a tolerance range. So 1 and 80% relative humidity, and it needs to be between 1 and 23 degrees. That's roughly room temperature in Celsius. And so I'll create this transaction. And that transaction is being created. Here it goes. Now what's happening is the website sent a REST call to the API gateway. It formatted a message, put it on service bus. It's being consumed by the microservice that formats the transaction, signs it, and posts it to the ledger. And then we pick it up, put it into the database, and the UI here refreshes for you. So I'll go into that contract. Now it's been created. And I'm going to transfer that shipment to a shipper. And I'm a cheapskate, so I'm going to use shady shipping. And so now, yet again, this is another transaction that's being driven by the UI through that same API, service bus, blockchain, microservice blockchain, back to the database, and so on. And so now it's been transferred over. And I can see that occurred in block 6553, and here are the blockchain details if I care to go into those. And if I had more parameters that I needed to fill in there, like I transferred responsibility at this location or in this jurisdiction, I could put those in, and those would be reflected as data items in that list as well. Now, before I go ahead and kind of do the interesting thing, I just want to show you this phone, which is running a Xamarin app, which is using the C# wrapper to the REST API that is available in the GitHub. So you can use that as well, either for mobile or anywhere. And by the way, there's also Java and Python. So depending on the language you like, you can write your clients in the way that you see fit. List of transactions, and here's the one that I just created. It's in transit. You can see I transferred it over to Shady Shipping. And this is logged in as Shady Shipping right now on the phone, again using Azure Active Directory. So I'm going to leave that up. And I'm still not going to melt the ice cream because I want to show you another thing, which is what is going on at the back end to make this all work. So I've got a logic app. And the logic app is monitoring the event grid for messages. And when those messages arrive, that logic app will receive that message and then process it. And this is my way of extending the workflow capability that's available inside a Workbench with whatever arbitrary logic I'd like. So I want to receive a notification in the truck if the ice cream is melting so I can make sure that the freezer's on, let's say. So let me go into this Send Alerts logic app. And if you haven't used logic apps, it's a very cool service, totally serverless and simple to get these things set up and to modify them, and also to troubleshoot when things go wrong. And so I'll just zoom out so you can kind of see the whole canvas. Basically, what I'm doing is I'm monitoring event grid, and then depending on what kind of message I'm getting, I'm taking different actions. So when a resource event occurs from event grid, depending on the type of message, I will go do different things. So there's insert block, insert transaction, update action, account created, etc. So let me go into contract inserted or updated. I'm going to check to see if this is a new contract, and it is. So then what action was it that was executed? Oh, it was ingest telemetry, which is what that device is going to do. And for each ingest telemetry, I'm going to look at the parameter. There are a variety of parameters in the telemetry message. I need to iterate through them. I'll find the one that is compliance status, and that tells me whether it's out of compliance or not. And if it is, then do something. Maybe I'll send a text, I'll call an Azure function, and I'll send an email. And I could call Salesforce, I could call Adobe. There are hundreds of connectors for logic apps. So you can extend this in any direction that you like. You can also add your custom connectors, and I'll show you that as well. Over here, I've got a new logic app that is empty. It doesn't really do anything. I just decided I'd run it on a recurrence trigger. But I could run this in response to, again, a CRM system being updated, or a new message showing up in an event grid, or some data being changed inside a Cosmos DB. And so any kind of action that I might like to trigger off of, I can. And so let me go ahead and add a new step. I'll just add an action, and I'll say, what is it? Blockchain Workbench, I think we said. Is that it? Yeah, okay, so Blockchain Workbench connector. So I've added a connector, which basically here surfaces the REST API that exists in Workbench. So if I have some off-chain process over here that needs to drive activity on the blockchain, well, I'll just wire it up with this connector, and then boom, it calls that REST API. And if you prefer messaging, you can do that as well. You can send a service bus. I also should probably show you that REST API. Let me do that. You get an API endpoint when you deploy. There's a variety of different capabilities here. You can interrogate the set of applications that are deployed, deploy new ones, configure them, et cetera. You could look at the individual contracts that are deployed, the instances of those applications that run, and you can get their status, and you can drive updates to them. So all of this should be relatively familiar, and if you learn the object model, which is fully documented on docs.azure.com, you'll be able to then follow what goes on here. The other thing I wanted to show you is this. Since the data is in a database, you don't have to do anything special to report on what's going on in your blockchain. Because really here what we're saying is blockchain could be the system of record for a large consortium of organizations that are all sharing data. It might be interesting to introspect on what's gone on. So you can use Power BI, you can use SQL Server reporting services, you can use your own data analytics solution, whatever other one you want. It all is just pulling from Azure SQL, so it's the standard SQL reporting story that you are already probably used to. So all of that is there. So let me go back to my mobile app, and I'll just back out and we'll kind of watch that. And then I'll go back to this guy. And so here I have my ice cream. It's in the truck. And here I have my wife's Vidal Sassoon Model 1875 hairdryer. And I will now melt the ice cream. It's not a big piece of ice cream. It doesn't take very long. I don't want to blow a circuit breaker. Okay, so now what should happen is I should be notified when that message is delivered to this instance. And so here we have this IoT device that's talking to that gateway. That gateway is sending a message in its standard format to the IoT hub in Azure. IoT hub has a filter, a route. It's not sending every single ping. And I'm going to need volume on my phone if I don't have it. It's plugged into the device here. Now, every single message that goes to IoT Hub doesn't generate a message to the blockchain. That would be voluminous, and you wouldn't do that for most applications. So we filter at IoT Hub with a route that says, hey, only if it's the temperature is above a certain threshold is this message going to go through. Then it triggers a logic apps that formats it correctly, posts a message to Service Bus, and then Service Bus picks it up, puts it on the ledger, and then we pick it up, and we should update here. Now we'll see. This is the trickiest part of the demo. Wait for it. Wait for it. All right, I'm going to move along, and we're going to see what happens. If we get notified, you'll know. All right, I'll take it. If that's the only thing that doesn't go right in this demo, I'm satisfied. Okay, so what I really wanted to show you is that With Workbench, you don't have to be some deep blockchain expert in order to build enterprise blockchain applications on Azure. You can, with relative simplicity, work this into your existing IT footprints, connect it with existing business processes and existing IT systems. And whether it's interacting with people or devices or services that might be available through those connectors, all of that is straightforward and simple. And the beauty of that is that you are not then focusing on the administrivia of setting up an end-to-end application. You're really focusing on the business logic, and you're figuring out how to integrate that with your IT footprint and extend it. And so, like, this is we think, a democratizing step that will enable blockchain to work for you in whatever context you'd like to use it. Let's talk about what our customers are doing, because I think it's a pretty interesting set of things. These scenarios that our customers are touching on fall into really kind of three categories. The first is they're tracking the provenance of an asset. It could be a physical asset, like something flowing through a supply chain, or it could be a digital asset or a financial asset. And they want to know, they want to have the ability to pass it around. And so Bitcoin, I think, was the first cryptocurrency asset that you saw with this pattern, but it could be any kind of asset. The second thing that people are doing is they have some kind of cross-organizational workflow. Let's say there's an agreement that needs to be reached among a variety of different counterparties, and all those counterparties have to provide some input and then sign. And the inputs that the subsequent ones provide maybe depend on the first one. So it could be a syndicated loan or something like that, or a trade finance instrument like a standby letter of credit. So that workflow can be orchestrated across these different parties using blockchain. The third category is they've got some process, whatever it is, and they need to prove that that process is running in a trustworthy way. And so they end up auditing that process, and they can essentially share the ledger that audits that process across a variety of parties. Maybe all the participants, maybe there's an auditor involved or a regulator involved, or they simply want to be able to demonstrate that the history of what's gone on has not been tampered with. And so they put it on blockchain, and they've got the immutability characteristics of the blockchain as evidence that they haven't tampered with the data. Three specific examples of customers who are doing interesting things. 3M, is a company that does a lot of chemistry, and they invented this label, which I have one of, which has interesting properties where if you open it up, it changes color, and you know that it's been tampered with. And so they're securing supply chains with this, putting that label, a very inexpensive device in a sense, over the top of, let's say, a pharmaceutical bottle. And then as it flows through the supply chain, they can have a mobile reader that will scan a QR code and determine whether the thing's been tampered with. And they're using blockchain to determine who had possession of the stuff when it was tampered with. And so you can then, first of all, stop adulterated pharmaceuticals from entering the hands of customers. Not only that, you can also hold the responsible party accountable for that. So that's one of the things that 3M is doing, which is a physical goods example. Let's talk about a digital or financial goods example. Maersk has thousands of vessels sailing around the world. On any given day, they might encounter bad weather or pirates, or they might sail through a war zone. And the risk that they're exposed to varies greatly. But the process for insuring those ships is so onerous, manual, and long-running that they only really do it once a year. And they end up having to insure at a much higher level of risk than the average day that the ship goes through, because they need to make sure that they're covered in the peak events. And there are some conditions that they can dynamically trigger, but it's a huge problem for them to trigger those conditions because they've got to get on the phone and call and sign documents, and there are a variety of counterparties because they have a broker, Willis Towers Watson, and they have insurers like MS Amlin and XL Catlin and others around the world that all need to then update their records. The premiums change, the coverage level changes, and it's a major deal if a ship sinks. There's a large liability for the ship and potentially the cargo too. And so it's not like this is something that can be done willy-nilly. It's not like, my buddy called me, I bumped up your coverage. Maybe you could do that for your home. Probably not, but maybe you could. You can't do it for a ship. And so what they're doing is they're actually putting together this dynamic system where that insurance coverage is reflected on a blockchain, and smart contracts govern the coverage levels and the premiums that the insurers offer. The broker, Willis, enables them to match. And then Maersk, the customer, has dynamic coverage. They're only paying for what they need. And we're working with Ernst & Young to sort of orchestrate this entire consortium. And so there, you could say it's a financial instrument, an insurance policy. And then if you look at Webjet is a travel company, and you can book hotel rooms through their website. It ends up that those hotel rooms flow through this supply chain, where you've got hotels selling to distributors who sell to aggregators, who sell to travel agents, who sell to customers. And those hotel rooms are represented in blocks and paper contracts, and the paper contracts are, they have complicated terms and conditions, and every once in a while, these counterparties don't agree who owes each other what, and on a monthly basis, they have to true up and reconcile and pay each other. And so what Webjet did is to create a consortium among travel companies to load up the blockchain, each with their own view of what the supply chain for hotel rooms looks like, and then they can detect where they differ immediately. It doesn't replace their booking system, which is the mission-critical thing that they've been running for years and they're happy with. It's a side system that enables automated digital reconciliation so that across all these organizations, they're not doing a whole bunch of manual work to determine where things are out of sync. They call that res chain. So these are 3 real customer scenarios. I would like to invite up Corey Haynes from our partner Aptus, and Corey is going to talk to us about what they're doing. And I will hand this over to you.
Thank you, sir.
Yeah.
All right.
Thanks for coming.
All right. Great. That was good. So glad to meet you all. My name is Corey Haynes. I work at Aptus. So my role is a global financial services vertical head, long title. I run the financial services industries portion of it. And one of the things that, let me give you a little background about our company. Software company, SaaS, 1,300 employees, still small, private, 500 plus customers, million users, et cetera, et cetera, et cetera. The big thing here is that one of the things that we've realized with all the industries that we deal in is really financial services has really become one of the key areas that we're focusing in. And some of that's because of me, some of that's because of our customers. But the real storyline there is that what we're seeing is that from a software company, what we're really focused on is what we call contract lifecycle management and also configure price quote. All that means is really enabling the middle office to be more productive. And so what I mean by that, customers come in the front end, usually websites or calls or phones. Hey, Mike Galeris, that's my Migos right there. I call him Quavo, but you guys don't know about Migos. But anyway, so the whole storyline there is that when we focus on contract lifecycle management and configure price quote, helping the middle office move forward, the idea is that financial services firms always have this quagmire in the middle of how did they actually move client, money, contract to actual fulfillment. And so what we've been able to do is focus in 4 areas and really help them and do that. So when you think about insurance and retirement, a lot of this is B2B. So you heard about some of the things happening in Maersk, but from a B2B standpoint as a business, when you have retirement services, most of these firms want to offload mutual funds and ETFs and sell them to plans. So if you are in a company with a 401k, somebody sold that to that company to sell you those 401k, to sell you that 401k with products on plan. Well, the ability to do that contract and put those projects together, price it, all happens in the middle office. And we use our software to streamline that. So people aren't doing that, putting the contract, writing it, lawyers aren't writing it, drafting it, putting the prices there, how much assets under management, how many participants. We automated that process. Same thing with wealth management. We do the same thing on the capital market side for master service agreements, NDAs. When you're starting a new product or you're starting a new product line, businesses want to do that. Banking and payments as well, and then fintech. But I'm not here to talk about so much what we do at Aptus. I want to talk about the blockchain portion of what we're doing, especially smart contracts. But I think it's important for you to set the context of how we're really thinking about blockchain. And as different ones are from software companies or even some businesses, you're thinking about, well, how do I start? How do I engage in this? So one thing that we did is, if you remember the 2015 movie, The Big Short, it was a really good caption of what happened during the whole crisis from 2007, maybe to 2010, if you want to say that. And, got Michael Lewis' book, was nominated for an Oscar, actually won the Oscar for Best Adapted Screenplay. Really great narrative of telling that whole cycle and story. But really, the context of that story was really one of those opportunities that we saw and our clients saw is, how do we remediate that? So what I'm trying to show you is that there has to be a business problem that you're trying to solve. It's not just cool tech and this is the latest thing. What's the business problem? And this was a primary business problem from some of our financial services firms, is saying, look, one of the biggest factors of this whole 2008 crisis was what we call loan securitization. Now, loan securitization isn't bad, but the process of taking a mortgage and packaging that mortgage and bundling that mortgage and then selling it and insuring it and not knowing what's in those contexts, that's the bad part. So this is where we started with our business problem of saying, let's tackle this for this client and really talk about this issue. So just a little context, right? We flash back 10 years ago, maybe even go mid-2007, right? And you think about what happened mid-2007, the crash started to begin. So the feds started to raise prices, and then all of a sudden you started to see people like Bear Stearns, AIG go out of business, foreclosures happened, Mozilla happened, TARP and all that. But that's just kind of the storyline, right? What we really saw underneath this is, and again, it's important to understand the context, is what we call the four horsemen, right? These are the four horsemen that really led to this, and then we'll slowly start to tell the story how we got in there. So number one was deregulation, right? And so wherever you stand on the political spectrum, deregulation started to help offset or started to enable and kind of lubricate the activity to start creating opportunities. So Glass-Steagall Act 1933 separated banks. After that, we got repealed. You started to have banks start to say, hey, we could take deposits and use it for derivatives, right? Derivatives are basically being able to trade offside the market, right, and create derivatives of that. Number two was securitization, as I mentioned. Securitization has been going on for years. It wasn't new to 2008. Fannie Mae, Freddie Mae have been doing that for years. And the whole purpose of GSEs, government kind of quasi-entities, is to make sure that banks have liquidity. So as you and I get a mortgage and a loan, these banks can't take all our loans because after a while they'll say that's all I can take. So what they do is say, hey, we'll help you get a mortgage, and that's probably a high mortgage here in Seattle and San Francisco and those on the East and West Coast. But they'll package that security and say, okay, some of these we'll keep in-house and some of them we'll sell. So as a bank, if we sell some, then we could take more customers and bring more in. And so Fannie and Freddie Mae were set up to kind of buy those loans for banks. So securitization has been happening. It really had a big boom after World War II when all the vets came back and you had the big buying boom. But one of the things with securitization is that whole packaging, right? And that's where we're going to focus. Number three is what we call the whole idea with the CRA. And this was the idea that CRA is the Community Reinvestment Act, that banks had to look at communities that were underserved and basically say, look at all these communities are redlined. They've been redlined for poor, for reasons of economic issues, you could say discrimination issues, whatever. So we need to start lending to these communities and make them a part of the American dream, so forth. So loans were being issued to these poor communities to help them, fulfill the dream. And it was all a beautiful picture because the fourth thing that caused that was the Fed interest rate. Interest rates had dropped incredibly, right? Greenspan was in power. Fed rate dropped to about 1.25 to create some traction in the market prior to 2007. So with that Fed funds borrowed rate, you and I would get a mortgage maybe 200 basis points above that, 3%. That's a great idea to buy a home at 3%. The mortgage is really cheap. You can buy it. Great idea. That all works good until the rates go up, right? And then you see the domino effect that starts to occur, right? Rates go up. I bought a mortgage. I was paying $200 a month or $2,000 a month for this house. Now it goes up 100 basis points. I'm paying $4,000, right? Doubles instantly. I can't afford it, right? So what happens? All of those, I start to foreclose. Well, that seems like a personal problem, but the problem with that is the securitization. That loan was packaged with a whole bunch of other loans. And so sometimes you package those loans with 4,000, 2,000 loans. And so as these little, as I call them, bad strawberries in the smoothies go bad, all the smoothie goes bad, right? But no one tastes it at first, but then you start to realize I have so much penicillin in me, I should be inoculated for the next 40 years because of all that mold that you're eating. So this started to create a domino effect, and then you could see kind of what happened. People like Bear Stearns who were buying these derivatives, who were saying I want it, AIG who was insuring them from a CDS standpoint, they started to fall apart. And so all of these things start to lead to the 2008 crisis. But a lot of that could be prevented with better transparency, with being able to see the ratings, being able to see what's going on. So this is where the business case starts to develop, right? So let me just take you through the traditional loan securitization process because, again, I think it's important to understand the process and then see how blockchain, which we'll do a demo on the smart contract side, to see how that works. And one of the things I might interchange sometimes, I may say distributed ledger, blockchain. Well, we're finding like a lot of our customers are liking the distributed ledger on the financial side portion of it because it's a little bit more contained than just a traditional block and a little bit faster, but we can talk about that later. So as I mentioned, right, the homeowner, right? We'll use Wells Fargo. You buy a home, 234. That's definitely not in Seattle, but somewhere in the United States, you can buy a home for $234,000. San Francisco, you can get a studio on the lower, in a very bad area probably for that. So then you get the mortgage, and Wells Fargo says, great, I have the mortgage, and I'm going to sell that, right? And I'll sell that loan to Goldman Sachs. So like I said, they're going to keep a portion on their books. In other words, they keep the loans in-house, you pay the Wells, and some of them they're going to sell. Well, Goldman Sachs says, great, I will be what we call the mortgage-backed security issuer. In other words, I'm going to sell those for you, and I will be the trustee to own that mortgage and sell it out. Or I'm not sell it out, I'm not going to own it, I'm going to give it to folks like trustees like Deutsche Bank. Deutsche then buys that mortgage pool, right? And so what happened is Goldman is going and buying mortgages from Wells, they're buying mortgages from Bank of America, they're buying all these different mortgages, and they're buying them what they call in tranches, in pools. And so you can imagine my mortgage, with your mortgage, with everybody's mortgage in here is all tranched. And what we're trying to do is say that some of these things can be resold on the market. Why? Because the marketplace wants to get that. It's a great, when you think about mortgages in general, it's a great investment. 30 years, a person is paying this consistently. And they have all the reason in the world to make those payments. Why? That's where they live. That's where their kids are growing up. So it's one of the predictively safest investments, so to speak. However, the problem is that when you start getting asset bubbles that happened in 2005, I'm no longer buying a home for me. I'm buying a home to rent out. And some of that is even happening now where people are buying homes to Airbnb, right? So we're kind of seeing this happen again. So again, some of our customers are saying, we see this trend happening again. We want to use something like smart contracts to prevent it. Keep going down the story. Mortgage is pooled, and you see in this demo, it's pooled with 2,000 other mortgages, right? And each of those are scored. Now the problem is you rated me at a steady state. So in other words, I will be rated as non-prime, subprime, prime, depending on my FICO score, depending on my loan to debt ratio, all of those other issues. But it was at a point in time. But as payments are missed, as things are happening, you don't see that. And that mortgage is packaged and sold as a great mortgage this person was paying. The first 3 payments were perfect. They had a 780 credit score. They were just excellent. But during that whole process, I could drop down to a 600 credit score because I didn't make the payments after that, and you would never know. Right? And so all these trustees are selling these pooled tranches, and then they're going to ratings companies like Fitch and saying, it looks good. It was on paper, 780, this was what the paperwork said. But there's a lot of paperwork being scanned back and forth, papers being lost. And one of the biggest problems that happened in this period of time, the investors could be all the way down to you and I. We could buy one of these in an ETF or mutual fund factor or a large pension fund, right? So the investors who have getting these funds are a huge range of institutional all the way down to retail clients. And so we have no idea that what we've bought because it's all been packaged, all been cut, and all been sliced and diced, right? So that was really kind of the process, the traditional process of securitization. And again, it was working great for 30 to 40 years until what happened there is that it got a little bit out of hand when the fact that, as I mentioned, some of the 4 things that kind of drove the marketplace to go to the bottom. So what we saw is that from our client standpoint is saying, look, we want to make sure that, we need something that is going to give us one source of truth, right? And this is where the business case starts to be developed. If we can make sure that the loan info and title are transparent and immutable, we won't have to worry about when I buy that mortgage and it goes to somebody else that it got changed. Because along the way, I can change all of that information, right? These are paper documents. When you sign a mortgage, you're signing with a title company and you're sitting there for a long time putting all your signature on that. That's all paper. If I can make that codified, in other words, I start the mortgage in paper, maybe even the legal department puts together and negotiated, but at the moment that we have to send it out, all of those terms and conditions become code. So payment is not made, therefore we go into default, start foreclosure proceeding process. Code says send a node over to the state house and to the county and let them know we need to begin foreclosure process. There's no communication as far as emails or mails or letters. It is all codified now, starting to send to these different nodes, and these state and local counties can just plug in to see that information, right? Loan servicing performance goes faster, right? Because now it's a faster performance. The SPVs, like we're showing the Goldmans, they have a smart contract, so they know special instructions of what happens with that. The rating monitoring now is immutable and can be done on the fly. So as I was saying, as things are changing in that pool, the ratings companies now are looking at a state and time. They're looking at real time what's going on with the mortgage as those payments are made. So if a payment is missed, all of a sudden that AA rating goes down to, or AAA rating goes down to AA. AA goes down to single A, goes down to A minus, goes down to B plus. So all of a sudden, all of that is information on the fly that everyone has. As I said, real-time information. And then from a security standpoint, we are able to see, what's going on, and the information is always available to investors. So when you think about, again, the loan level data, the servicing of the contract, all that happens within there, everyone on this slide is now notified of what goes on and is happening throughout the mortgage process. And even the point of when you're making mortgage payments, that initial information is going to the right people, and making sure that your loan stays approved or you don't have any issues with default. So with that, we'll go into our demo, and we'll have Cliff really talk about how we actually started to build this. But I think 3 things I want to leave you with is when you're starting this, make sure you have a business issue. Find the value proposition. What are you trying to solve? Number 2, what helped us is working with a partner like Microsoft to help us accelerate that, right? To help us bring that to life sooner, because customers want to see what you're talking about and you can show it to them. And then number 3 is going to be iterate, iterate, iterate. Don't try to solve it all at once. Try to iterate along the way, which Cliff will show you. And then as you're iterating and getting the client involved and seeing the adjustments, you're able to move faster. All right? So with that, I'll turn it over to Cliff. Thank you very much. Great job, sir.
Hello? Perfect, that works. How are you all doing? Let me adjust this a tiny bit because I'm going to need both of my hands in a second. All right. So I'm Cliff Goodwin, and I'm a senior sales engineer here at Aptus, and I've been working with Corey and Microsoft for around 6 months. We got into a preview program relatively early to have a look at App Builder, back then, now Workbench. And we've gone through its various iterations. And right now I'm going to take a second and walk you through a little bit of what we've come up with. If you give me 1 second to get this on. Here we go. Perfect. So by now you should be relatively familiar with this screen. In my case, I'm going to show you this screen from a developer's perspective. As you can see, the number 1 thing pointed out here is the immutability of blockchain. Every iteration, every time I screw something up, I just redeploy. Luckily, the Workbench makes that very simple. So right now, I also prepared a 30-minute presentation on how we would actually go through configuring those loan bundles and creating the actual contract in our contract management system and the complex integration to the Workbench, but they advised me to skip all of that because you guys really care about what I actually did in here. So the first and most important thing you'll see when you come in is that there's something here. There's a UI. This is big. Out of the box, I got a UI so that I could just focus on tossing in my Solidity, tossing in my JSON, bam, see the business process work and whether the logic, as is evidenced by how many loan securitization examples you see, was flawed or not. But beyond that, where we're actually going within Aptus is completely replacing this UI for the first user in this scenario. The UI that we're going to have in place is going to be our internal product UI because, again, we're an application company. We sell quoting applications. We sell contract management applications. We sell approvals applications. We plan for users to actually interact with the blockchain internally using whatever their business system is, well, whichever business system we sell them. For all the external parties, because keep in mind, the whole point of blockchain, well, the major benefit of blockchain technology is the ability to do these multi-party interactions. All of the other parties involved, the external trustees, the buyers, the auditors, all of them can interact immediately through this UI if we don't choose to reskin it. That being said, I again am going to walk you through actually creating an application in Workbench, but I'm going to show you from a dev's perspective what I find to be the most revolutionary, what I find to be the most revolutionary change that came. A couple weeks ago, they added this little thing. Previously, uploading contracts, JSON, Solidity, you didn't find out until your Solidity didn't compile when you tried to submit a transaction. It wasn't too fun, but now we've gotten to the point where as I upload these files, I get real-time feedback, and in fact, it's not showing right now, but it actually shows me line-level details about where I left something out. In addition, it matches the config file against the Solidity contract. And if it finds discrepancies, if I've referenced the state in my smart contract and I haven't configured it within the state section of the config file for the UI to be built, it tells me, it says, hey, look at line 131,9, you're missing a state, so on and so forth. Now, my second favorite thing about this, and as Matt said earlier, this was when I was sold on the application after having worked on a few projects and POCs where we had to tackle similar problems, was the fact that this was fully integrated with Azure Active Directory. Identity management is a pain in the behind because in truth, nobody really wants to spend 3 days trying to figure out how to map users in one system to users in another and build all of the integrations, so on and so forth. With this, I have smart contract level I have smart contract level application roles, and I can just build the logic within my contract to obey all of that. So right now I'm going to go ahead and click into my loan securitization contract. Yeah. First I'm going to refresh. Here we go. And the first thing I'll do in here is, actually let me back up 1 second and I'll introduce you to the roles that are going to play out in this scenario. So as Corey was saying, there are five major players in a loan securitization example. And again, we've simplified this greatly and in fact simplified the bundle of loans down to a single loan just so it's easy to digest the first time you're seeing it. Well, there are 5 major players in this orchestration. We have our bank loan treasury. That's who I'm going to be playing primarily. That's the guy inside the bank who sits down and says, hey, I want to bundle these loans up. I want to create a tranche of loans. From there's the bank oversight. You could think of them as your internal approvers. Before anything can be published can be picked up by an external trustee, it has to be signed off on internally. Pretty common process. Third, there is the external trustee. This is where the Goldman Sachs sits on Corey's slide. Next, we have our ratings agency. This is another third party that then looks at this tranche, at the rebundling that Goldman Sachs has done and applies a rating to it. And finally, we have our buyers. And again, this process happens over and over and over. One loan goes into a tranche, which goes into another tranche, which goes into another tranche, and sooner or later, no one has any idea what's in anything. That being said, right now we're going to go ahead and create a new loan securitization contract. And again, we would actually do all of this through the REST API from our contract management application. And we'll just name this 123. Set the value at $1 million, add 2 stipulations, a duration of 3 years, a yield of 2%, account ID, zip code, capturing all of this information, all of the things that well, in this example, the primary things that we would want to attach to this loan to pass on through it, with it, through all of the different versions of it being bought, sold, so on and so forth. And for the rest, we'll just toss in some values. From here, right now, we're reaching out through that REST API and actually creating the block. Well, I should say, creating the smart contract, and it's being added to a block. And from here, you can see, and in fact, let me make this a tiny bit bigger. From here, you can see that this loan is in pool, well, that this smart contract is in pool created status. That's our first step. So going in, again, you'll see a lot of the details for this loan, but one of the most important things here is just noticing that we have a timeline, date and time stamp. Every action is recorded and shown to us right back through the UI. One of the other things you'll notice is that the user I'm logged in on has no actions. We built a very generic workflow, and essentially the way this works, once this bundle of loans is created, this initial tranche, once it's actually sent out for internal approval, the originating party can't actually edit it. So from here, I'm actually going to pop over and log in as my approver. Here, Cliff Approver can see many of the different iterations of the loan securitization example, but specifically when he logs in to this example, he has an action. He can see that Cliff Goodwin called create, the bank treasury created this tranche, and when he clicks in, he can see an overview of what happened in the last action, what the last state change entailed, and he has a couple options. He can either validate this loan pool or he can reject it. In our instance, we're going to go ahead and go with validate. And you'll notice that the moment he chooses validate, he gets a number of options. He gets a number of fields for him to add, because again, this is the internal oversight at the bank. Most buyers at the end would love to be able to see, hey, the bank did assess this loan pool and they assessed it with risk model C or with a loan-based risk model, so on and so forth. So we'll type in risk model C, and we'll actually sign off that Cliff.approver went through all of this. Well, we're running out of time, so I'll give you a brief overview of how the rest of this flows. Essentially, from here, this loan tranche moves forward to being picked up by that external trustee, and the most interesting interactions happen from there. You can imagine that this external trustee is actually going to put this loan up for sale. However, it's the actual bank oversight user who's going to be approving or rejecting that sale, because that transaction is still between the bank oversight user and the buying party. It's not actually with Goldman Sachs. That being said, one of the key points I wanted to point out is that although we're showing all of this to you in the context of financial services, a complicated buying and selling scenario with multiple parties like that is applicable across industries. This directly mirrors the distributor model. And with that, I'll go ahead and pop this off. Thank you.
I wanted to say two things. First, we don't have time for Q&A, obviously, so please just all come to the booth. We're going to get a bunch of people there. We'll chat with you there. We're over on the expo floor. Come to the Azure Blockchain Workbench booth. And go check out the deployment and check out the docs and try it. So we repointed our deployment this morning because we had an issue with the main one, And then I had some problems with connectivity. So I've now paired this phone, I've paired this phone through an LTE connection. So I'm going to try to deliver the very end of the demo to you right now. We're going to see if this works. Let's give it a shot. Here we go. And I should have sound through the phone plugged in through this device. All right, so let's see if we get this now. Let's give it a try. I hope it works. There's a nice payoff, but if it doesn't happen, it doesn't happen. This phone defaults to Wi-Fi calling. Oh, there we go. So I just got a text, refrigerated product at risk, and now I'm receiving a phone call, which should be coming through the audio.
There is a potential food safety issue that needs your attention.
There you go.
You are receiving this message to alert you to an issue with a shipment being handled by shady shippers. Your shipment of ice cream is likely melting and no longer in a sellable condition. To have the shipper return the product, please press 1. To have the shipper destroy the product, please press 2. To override this alert and allow the shipper to deliver the product, please press 3. We have recorded your response of 2 and will communicate it to the shipper. Thank you, and have a nice day.
You laugh, but we have customers who have consortiums involving counterparties with only feature phones, and this is their only way to interact with the system. So IVR actually becomes important, and so that's the Twilio integration that I showed you before. The Azure function calls the Twilio IVR API and then connects the dots. Thanks so much for coming. It's really been a pleasure speaking with you. Come by the booth and ask questions.